To develop an object in the space of a one-point perspective, begin by defining its footprint on the floor plane. The diagonal point method for constructing a one-point perspective enables us to obtain accurate depth measurements directly within the perspective view. To illustrate this, begin with the square elevation of a cubical volume coincident with the picture plane. Establish the horizon line at the height of the spectator's eye above the ground plane. Establish the spectator's center of vision on the horizon line. Through the four corners of the square elevation, draw the receding horizontal edges of the cubical volume. These lines are perpendicular to the picture plane and converge at the center of vision. The question is how to determine how far back the rear face of the cubical volume is. If we could draw a 45-degree diagonal from one of the corners to the opposite receding line, it would mark off a depth equal to the base length of the square elevation. A plan view of the perspective construction shows the station point of the spectator and the cubical volume as a square with its front face coincident with the picture plane. To find the vanishing point for the diagonals of the square plan, we draw 45-degree lines from the station point parallel to both diagonals until they meet the picture plane. These vanishing points for 45-degree lines are called diagonal points. The distance from the center of vision to each diagonal point is equal to the distance from the station point to the center of vision. In the perspective view, we establish both diagonal points on the horizon line to the left and right of the center of vision at a distance equal to the distance from the station point to the picture plane. From one corner of the square elevation, draw a line to the opposite diagonal point. Remember that this line is a 45-degree diagonal that lies in the horizontal ground plane. Where this 45-degree diagonal intersects the receding depth line, draw a horizontal line to complete the base plane of the cubical volume. The base plane is a square since the 45-degree diagonal marks off a depth along the receding line, a length equal to the base length of the square elevation. The preceding example illustrates how the diagonal point method uses the geometry of a 45-degree right triangle and the principles of convergence to make depth measurements in perspective. The three-dimensional network of uniformly spaced points and lines enables us to correctly establish the form and dimensions of an interior or exterior space, as well as regulate the position and size of objects within the space.